Hello, this is Module 5, Video 19. This video is a review of where we're at so far. So I just wanted to take some time to have a look at what we've achieved so far and actually show that it is actually useful, and also probably address a couple of smaller issues that I've found in the process. So what I've done is I've created a simple view controller, this test view here, and this test view is a reactive view controller because I'm using reactive UI, and we'll get into the details of that later. But right now, all we need to care about is that it creates a button, and when you touch that button, it executes a test command in the view model. Now the test command, this is the view model. The test command is an asynchronous command that executes an exercise program. So what I'm doing is I'm actually creating an exercise program manually through code, rather than using the parsing stuff that we'll be writing next. So you can see here, create a new exercise program. I'm having to pass in all the services that I need as well. So passing the logger service here, giving the program a name, and then giving it a list of exercises or enumerable of exercises. And the first exercise here is push-ups. I've got 3 sets, 5 reps each. And then I've got this stuff here, which is the matches with actions. So the first one here, I'm matching any numbered, any before set event where the number is greater than 1. So that means any before every set except the first one. And then when that matches, I'm executing this break action for 7 seconds. So what that means is before every set except the first one, we're going to have a break for 7 seconds. And then the next matcher is matching the during repetition event, and I've got this metronome action which has 4 ticks. The first one's a bell, and then there's 2 clicks and then none at the end. So that will give you timing information for you doing your push-ups. And then finally I've got this matcher where we are looking for every second to last repetition, basically. So after a repetition, if the number is the number of repetitions minus 2, then we match. And what I'm doing when that matches is I'm saying there's 2 left. So it kind of gives you a clue, a hint that you've only got 2 push-ups left before the end of that set. So that's what I've got. Now, in order to show you this running, I'm still not having any luck with the simulator, having speech work in the simulator. So I have to run this on my actual iPad. And just before I run this demo, I want to point out that I've added 2 audio files here, MP3s, one for the metronome bell, one for the metronome click, and the properties are, build action as content. So that's that. So now let me run the app on my iPad and play back the exercise program to you, or at least part of it. So when I press this test button, this is our 3rd rep, so there should be only 2 left after this.
2 left.
There we go.
Break.
So this is our 7-second break.
Ready.
And then we go back into another set of push-ups, and that will happen, another set after this as well. So I won't bore you with the full exercise program, but there we have it. Now, I have noted 2 issues, and you may have noticed one of them just now as well. First of all, there is no announcement of the exercise program name, of the exercise name. So nothing tells you that you're doing push-ups, which is a bit strange. And I mean, we could put our own action in here to say push-ups, but why should we when the data's already in the exercise? It knows what its name is, so it could say it before it starts. The second problem was a little bit more subtle. The metronome wait periods we've got here, I mean, it was clearly a lot longer than half a second between the bell and the first click. And the reason for that is because we're waiting for the audio action to complete, and the bell just happens to be a long piece of audio, just kind of reverberates for a good second and a half, 2 seconds, and then it will start timing the 500 milliseconds after that bell audio completes, which is not what we want. We want to play the bell and start timing straight away, so we know. So the click may actually play when the bell's still kind of chiming in the background. So those are the two problems I've noticed. I actually fixed the problem with the exercise name not being announced, and I was recording it at the time, but then I found out that I'd recorded system audio, not through my microphone here, so I lost all that audio, which is a bummer, and I considered redoing it all and recording it again, but I couldn't be bothered, to be honest. So instead what I'm going to do is just show you what I've done. The crux of it really is just in this exercise model. We used to have this code here, just a link statement to find all the matches that match and then get the associated action. And what I've done is change that to kind of inject a say action here. If the event is before exercise event, then we inject a say action, and we give it the exercise name to say, and then we do exactly the same logic as we did before, although I've rewritten it as as a for each loop and with a yield statement instead of a link query. But that's the crux of that fix. Now, it did have some propagating changes because we now require a speech service from our exercise model. That means that I needed to change the constructor, I needed to update the unit tests, etc. So it's a bit of a pain, which is why I don't really want to do it again. But the actual fix is very simple. So if I run this again, you'll see the difference. Okay, so here's our app again. So if I press test,
Push-ups.
this time it actually announces the exercise name, which is exactly what we wanted. So that resolves the first issue. Now the second issue is a little bit more subtle, and I wanted to spend a little bit more time talking about that before we fix it. So let me find metronome action is where it's at, and you'll recall that we've got this this logic to kind of get the inner actions, and actually we're just passing them onto a sequence action now. So each of these actions that we yield here are executed in sequence. So in the case of our sample exercise that we just put together, the first metronome tick has a 0 wait period and then a bell, and essentially that means this wait action's basically skipped over because it checks that the time span is 0 and it says, oh, there's nothing to wait for. So it immediately yields this audio action to play the bell sound. And the sequence action will actually await that audio action. And the audio action is itself awaiting the playback of that audio resource. So it's not like it fires and forgets the playback. It actually waits for that playback to complete. So if you've got an audio file that takes 5 seconds to actually play back, then executing this and awaiting the return task will take 5 seconds. And that's the crux of the problem, because this playback of this bell takes some time, and then we start timing the 500 milliseconds. Now, the ways around this, I mean, it might seem like a good idea would be to return the wait action and the audio action inside a parallel action, because then they both start at exactly the same time. But the parallel action still awaits all the tasks, all the actions within it. So if the audio action is longer than the wait action, which is entirely possible, then we've still got a problem because we're waiting longer than the delay that has been specified. So that's, and the parallel action, by the way, is correct in my opinion. It should be waiting for all the children to complete before it itself completes. Otherwise, it would be non-deterministic and difficult to reason about. So another option we might consider is changing our audio action so it doesn't actually await this playback here. It just fires it and then forgets about it. But again, that's going to result in non-deterministic, difficult to understand why this action's not awaiting when everything else does. So my thinking on this is that we create a separate action that is a decorator action. So we use the decorator pattern, and we call that action do not await action. And so all it does is takes an inner action to execute. Its duration is always 0, and when you execute the do not await action, what it does is executes the inner action and doesn't await the result. Just kind of adds a continuation onto that to log any errors or success as necessary, but it doesn't actually await for that inner action to complete. And that would allow us in our metronome action to wrap the audio actions in a do not await action, so that we're not waiting for the audio to complete before continuing on with the wait action. Now, the only issue with that I can foresee at the moment is testing, because at the moment we have deterministic behavior here. We know that the wait action is going to complete before the audio action starts, and vice versa. Whereas when we wrap this in a do not await action, there's a chance that these could complete in different orders. So our tests, which currently rely on the order of these actions completion, our test could break. So we will have to change the tests. But other than that, I can't see any drawback to this proposed approach. So let me flesh this code out as quickly as I can with some tests, and I'll explain it once I'm done. Okay, so here's the general gist of my tests. I'm doing the usual argument checking. So we're going to need to take the logger service and an inner action to execute. And duration is always 0 regardless of what the inner action duration is, because we're not waiting for the inner action. That makes sense. Execute async throws if the context is null. Execute async does not wait for the inner action's execution to complete before itself completing. So here I've got my inner action never actually completes. It just returns a task from this task completion source which never actually completes. Now despite that, when I call execute async on the do not await action, I assert that waiting for that does actually complete within 3 seconds. In reality, we would expect this to be much lower because it's got nothing to do, but 3 seconds is usually the kind of timeout that I use in my unit tests, so that's why I have that there. And finally, execute async logs any error raised by the inner action. So that this just ensures that if the inner action fails in some way, it's not going to bring our process down, and we will find out about it through our logging system. Now this is almost certainly wrong, but I'm not going to know the exact message until we get to that point. But basically what I'm doing is I've got a logger mock. The logger service returns that mock when it's asked for a logger. And then I have this inner action which throws when it's executed. And then I run the do not await action with that inner action. And I assert that, or I verify that the logger has its error method called. And, we'll get the exact message right shortly. Now, one problem with this, or one potential problem with this test is that I have no way of knowing when the inner action actually completes, because that task for the inner action is just kind of being discarded. So I have no means of getting a hold of that from my test and awaiting it. But because this throw here is happening synchronously, I don't expect that to be a problem in this case, but I could be wrong. We'll find out, I guess. First things first, I have to fix my constructor. Okay, so everything's failing as we hoped, so let me fill out this implementation. Okay, so there's the implementation. We are just returning 0 for duration, and we're executing the inner action, and then continuing, adding this continuation on here to check whether it's faulted and logging appropriately. And then, of course, we're just returning task.from result to true because we've got nothing more to do here. So let's try that. Okay, so I'm missing, or I should be using a loose mock object in a couple of places that I'm not. I've actually missed this assertion here. Okay, so that's 2 of the issues fixed, I think. Okay, it's because my exception behavior here is incorrect. I believe I need to do this as part or within a task. So what I actually need to do is return a task that actually throws. Okay, so now I think we're being hit by the issue that I mentioned we can't wait for the inner task to complete at the moment. In fact, we need to wait for more than that. We need to wait for the continuation on that task to complete. So the only way I can think of to get around this at the moment is to remove this verification and instead do it through the mock object itself. So when error is called with the appropriate message, I'm going to start with is any string because I don't know what the message actually will be. Then what I want to do is just set some wait handle. So manual reset event slim maybe. So now once we've called this execute logic, we can just await that handle for for my 3-second rule, and we would expect that to be true. In other words, within 3 seconds of calling execute async on the do not await action, we expect the logger to receive a call on its error method. So let me fix this. And if that call isn't received, then the unit test will fail. So let's try that approach. Okay, that works, but just to prove that it's doing what we expect it to be doing, let's just change this to a warning. To be honest, I don't really care that much about the specific message as long as it's, a decent message. And there you can see it waiting for 3 seconds. So that's now failed. Okay. So I'm happy with those tests. I'm happy with the do not await action. But now we need to use it from the appropriate points in our metronome action, which is going to break our tests. But the place where we need to use that is right here. Let's take a look at the test first. So I just think it's this last test that's going to be the problem because we're sticking all calls against audio service play async and delay service delay async into the one list. So we can no longer rely on the order of items in that list, so I think we're going to have to split it out into 2 lists. So first things first, we know the metronome action is now going to require the logger service, so let's change our tests accordingly. Okay, so now we can make the change to our metronome action to take the logger service and pass that through to a do not await action. Okay, so obviously now we need to pass through the logger service to our metronome action, like that. Okay, so that all builds. So just to explain what I've done there, we're now wrapping our audio action inside a do not await action. That's really it. Everything else was just to support that change. So let's try the tests. And everything is actually working. I'm surprised by that. I think there was probably a race condition in here. I suspect if I run this a sufficient number of times it will eventually fail, but maybe things aren't running synchronously that I think are running synchronously. Asynchronously. Very interesting indeed. Oh, of course, it's because we're actually doing this call synchronously. So this string is being added to our list synchronously, not asynchronously. There's actually no asynchronous work done by any of these calls because all it does is return tasks from result true. So our test can actually stay exactly the same and it remains just as good as it was. So that's a bonus actually that I hadn't considered. So now let's try running the app again on my iPad and see if it fixes the issue that we were trying to address. Okay, so I'm touching test,
Push-ups.
and already you can hear that it's not waiting for the bell to complete.
2 left.
So that's what we're after. Now
Break.
obviously that's too fast for normal human beings to do push-ups, but that's besides the point. That's exactly what we told it to do, and that's what it's doing. So that looks to have resolved that issue, and we've also got the push-ups being announced. So I think that's the two issues I wanted to address before we move on to the parsing logic. So I will catch you in the next video. Bye.